I am Anil Kumar. Welcome to my series on integration. Now we'll review with some practice test questions. Let me thank all the students who have joined in this learning process. You can always register at my website globalmathinstitute.com or send me an email on the given address. To review what we have learned, here are 6 questions. I'd like you to pause the video, copy these questions, and then look into their solutions. Question number 1 is to integrate x square root x dx when x is greater than or equal to 0. Question number 2. Square root of y is equals to 4 times 4th root of x minus 2 times x to the power of minus 1 over 4 when x is greater than or equal to 0. You need to find the integral of y dx. Question 3. Given integral of 5a over x cube minus 2ab dx is 24x minus 15 over x square plus c. Find the value of a and b. Question number 4. A particle moving in a straight line and has a velocity v of t in meters per second and displacement is s of t in meters at time t seconds when t is between 0 to 10, the particle's acceleration is given as a of t equals to 2 meters per second square. The particle has initial velocity v0 equals to minus 7 and s0 equals to 10 meters is the initial displacement. By finding expansion of v of t and s of t, determine when the particle is moving away from the origin. Question number 5. The cross section of drain pipe is defined by f of x equals to 0.02 x to the power of 4 minus 0.4 x squared minus 2.5, where x is between minus 5 and plus 5. Find the maximum depth of the pipe and find the cross-section area of the pipe. So here is the rough sketch of the given function. Question number 6. Given graph of f of x equals to x squared minus 6x plus 5 and g of x equals to x minus 1, find the area of the region enclosed by f of x and g of x and the x-axis as shown in shaded region, orange shaded region. So these are the 6 questions for you. You can pause the video, answer these questions, and then look into the suggestions. Now, in this particular set, we have learned that the integral of x to the power of n is x to the power of n plus 1 over n plus 1 plus c, which is going to be applied. And when you multiply by k, then the integral also gets multiplied by the constant k, right? The fundamental theorem of calculus part 2, we learned that if f is continuous function on closed interval a and b, then the integral from a to b of f of x d of x can be found by fb minus fa, where f is any antiderivative of f or f prime is equals to f. So these are the concepts which will be utilized to answer the questions. Question number 1 is relatively straightforward. We need to integrate x to the power of x squared times square root of x dx when x is greater than or equal to 0. So write it in exponential form. So 2 plus half is 3 by 2. So to integrate x to the power of 3 by 2, add 1 to the exponent, divide by that exponent, plus c is your integral. And when you simplify, you get x to the power of 5 over 2 over 5 over 2, which means 2 over 5 times x to the power of 5 over 2 plus c, where x is greater than or equal to 0. So that's the solution for the first question. Now let's look into the second question, which is given square root of y is equals to 4 times x to the power of 1 over 4 minus 2 times x to the power of minus 1 over 4, where x is again greater than or equal to 0. Find the integral y dx when x is greater than or equal to 0. Now in this case, we can actually simplify the given equation. Square root of y is equal to a radical function. Let us square both sides, right? So when you square both sides, we get y equals to square of the right hand side. Now applying the formula, a minus b whole square is a square minus 2ab plus b square. We go write this as 16 square root x minus 2 times 4 times 2 plus 4x to the power of minus half. Well, that can be written as 16 square root x minus 16 plus 4 over square root of x. Now we can apply the power rule to integrate. So the integral of y dx will be applying the power rule to the given function. We get 16 times x to the power of 3 over 2 divided by 3 over 2 minus 16x plus 4 times x to the power of half divided by half plus c. Now when you simplify, you get your integral in the radical form as shown here. So that is how this will be done. Let's move on and take the next example. In this case, we are given the integral of a function which is 5a over x cubed minus 2ab dx is 24x minus 15 over x squared plus c. We need to find the value of a and b. So that means you first find the integral itself. So let's find what this integral is. Applying the power rule, we get this as minus 5a over 2x squared minus 2abx plus c. Now we can compare the coefficients of what we found and what is already given to us. So comparing the terms which are kind of similar, right, you can get the value of a and b. So let's look into a first. Minus 5a over 2x squared equals to minus 15 over x squared cancels, right? And you can simplify and find a as minus 15 times 2 over 5, which is minus 6. So minus 6 is the value of the a. And the other expression comparing the other two, we get minus 2abx equals to 24x. Substituting the value of a as minus 6, we can now find the value of b, which is 2. So we got a as equals to minus 6 and b as equals to 2 as our answer. Let's move on and take the next example, which is a particle moving in a straight line and has a velocity v meters per second, displacement is meters at time t, seconds before, where t is between 0 to 10. So we have to work in this interval of 0 to 10. The particle's acceleration is given to us as 2 meters per second square. The particle's initial velocity, v0, is this much, and displacement is 10 meters. By finding expressions of v of t and s of t, determine when the particle is moving away. So we have to figure out when is the particle moving away from the origin. And we also need to find the expressions for velocity and displacement. So that we can find by integration of acceleration function given to us. So a of t is equal to 2. Integrate a constant, so we get 2t plus c as the velocity. And now we know the initial conditions, that v0 is minus 7. Substituting minus 7, we get c as minus 7, and therefore the velocity is v of t equals to 2t minus 7. Now integrate the velocity function just calculated. Now, so that gives us the displacement function as t squared minus 7t plus c. To find the value of c, we'll substitute the given condition for displacement, which is s of 0 is 10. So c is equals to 10. Substituting 10, we get the expression for displacement. Now we need to figure out when is the particle moving away from the origin. The condition for that is that the product of velocity and displacement should be greater than 0. In that case, it is moving away. Now to find this out, we need to consider the intervals after we simplify the expression for the product of velocity and displacement. We already have these two expressions, right? So we can use these equations 1 and 2 and find what is the product of velocity and displacement. So 2t minus 7 times t square minus 7t plus 10 gives us the expression, which can be further factored and written as 2t minus 7 times t minus 2 times t minus 5. Now see, this has zeros at 7 by 2, at 2 and at 5. Since these are the zeros, they divide the whole interval into 4 intervals, right? So the intervals are from 0 to 2, then 2 to 3.5, 3.5 to 5, and from 5 to 10. Since we are looking into the domain 0 to 10, all are in seconds. Taking test points in these intervals as 1, 3, 4, and 6, we can see that each factor is negative or positive as shown in this particular table. So for each interval, we have to test our factors. Once we have this interval table, we can multiply 3 negatives will give us a negative, 2 negatives will give us a positive, 1 negative will be negative, all positives will be positive. Positive indicates that the particle is moving away. So these are the two intervals in which the particle is moving away, and that becomes the solution for the given question. So the moving away, I should have written here, not speeding, but moving away. So it is moving away in these intervals. So that is how we are going to answer this question. Next question here is, the cross section of a drain pipe is defined by f of x equals to 0.02 x to the power of 4 minus 0.4 x squared minus 2.5 minus 5 minus 2.5, and we are working in the interval from minus 5 to plus 5. Now during this interval, this is all negative value as shown here in the graph, so it is not really crossing the x-axis. We expect a negative integral, but the area is going to be positive. Remember that. The question here is, find the maximum depth, that is this, of the pipe and find the cross-section area of the pipe. Now to find the maximum depth, you need to find the first derivative, critical point, analyze this critical point for maximum or minimum, right? And once you get that, then you know for sure what is the maximum depth. So let's begin with finding the derivative of the given function. The derivative of 0.02 x to the power of 4 minus 0.4 x squared minus 2.5 is 0.08 x cubed minus 0.8 x. Equate this to 0, right? You can factor and then equate it to 0. You get x as equals to square root of 10. Now, to analyze this, you can straight away analyze the first derivative, or you can find the second derivative and test it at square root of 10. So we prefer to do the second derivative. So second derivative is 0.024 x squared minus 0.8. At square root of 10, this is positive, right? So substituting 10 square root, we get here 2.4 minus 0.8, which is positive, and therefore the curve is going to be what? So the curve is going to be like a parabola opening upwards. So that gives you a minimum, right? So we get a minimum at x equals to square root of 10. Substitute the value to find what this value is, and it turns out to be minus 4.5. So the deepest point has a depth of 4.5. So we can say the depth of 4.5. Okay, so that is part A. Now for part B, we need to find the cross section, right? So cross section area you can find using the integral. So let's integrate the function given to us. But remember, area is always positive. So when you integral, you are expecting a negative answer. Take the positive value for the area. So area is positive of absolute A, but let's find the integral, which is A for us, from minus 5 to plus 5, f of x d of x. Now you can see from the equation that the function is even, right? So f of x has an even symmetry. So what we have done here is that we have only found the integral of 1/2 of it, and we're going to multiply that by 2. So 2 times from 0 to 5. So you could do that. So it becomes slightly simpler for calculations, ultimate calculations. The same function, correct? Now, when you integrate, this is what you get. So when you substitute 0, you get 0. So just find the value at 5. Substituting 5, this is what we get. And the value turns out to be negative 50 over 3. But now we have to take the absolute value of a. So absolute value of a times 2 is what is required. So that is positive value of 50 over 3 times 2. That gives you the answer as 33.3 units square is the area. Correct? So that is how we are going to actually find this particular solution. I hope the steps are clear. Let's move on and take the last question now, which is, given graph of the function f of x equals to x squared minus 6x plus 5 and g of x equals to x minus 1. Find area of the region enclosed by f of x, g of x, and x-axis. So the area which is marked in orange, this is the area which we want to find, okay, not that green area. So we have to exclude that green area. That's the whole thing, okay. So we want to find the area shaded in orange. So how will you do this? Well, first step is find the x-intercepts so that you know the points A and B. So these are our points A and B. Let me write them big, A, B, right? So that point is D and this point is C for us. Okay. So first step here is to find the intercepts A and B, then find the point of intersection C, and D is the projection of C on x-axis. So y value of C is the one which you're going to find the height of this triangle, and the x value will give us the length of this or the base of the triangle, correct? That's the whole idea. So let's begin by finding the x-intercepts. So x-intercepts are when f of x is 0. So when you factor, you get x minus 1 times x minus 5, and clearly the zeros are at 1 and 5. So the value of a is 1 and b is 5. To find the point of intersection, f of x is equals to g of x, and now we can simplify the expression. Bringing them all together gives you a quadratic equation which is x squared minus 7x plus 6 equals to 0, factored to x minus 1 times x minus 6 equals to 0, and the point of intersection is at 1 and 6. That means at the first x-intercept also the line crosses. So the cross section, so that means that there is also a point of intersection between the line and the parabola. So we get the point C here, which is 6. At x equals to 6, the value is 5. So point 6 is 6 and 5. So that becomes the common point which we are looking forward to. Now let's look into the area part. So area is kind of like this in this particular case. We have a big triangle. See, we have a triangle like this. Let me just do it separately here. So we have one big triangle here in which this point is identified as A, this is B, and that is C. So rather I should say that is D, right? So the point A is found at 1, this is at 6, and the value of C is 6, 5. So that is your big triangle. However, the curve is going like this. Correct? So we need to find the area which is within this part. So the idea is, first we'll find the area, the bigger area, which is the area given by A1. A1 is the area between g of x and x-axis, so the triangle. So this is the right triangle, where we know that the base and the height is given by the y value, and the base as the difference between 6 and 1, which is also 5. So we have this area now. So area of the triangle A1 is half base AD times height CD. That gives us half of 6 minus 1 times 5, which is 21 over 2. That is first part. Now we need to find the area which is shown in this end. So this area is actually the area under the curve with point C and the point B on this side. Correct? So we are now considering this area. So that is A2 for us. So A2 is the area between f of x and the x-axis when x is changing from 5 to 6. Correct? So then integrate this between 5 to 6. The function is x squared minus 6x plus 5 dx, right? Which is f of x. Here is the integral from 5 to 6. Evaluate the value as shown here, and you get that to be 7 over 3. So you have to take away area of 2 from area of 1 to find the answer. So that gives you the solution. So when you take away the area of that portion, which is under the parabola from 5 to 6, from the triangle area, then you get the solution, which is 10 1 over 6 unit square. Correct? So when you find area between the curves, you have to be careful what you need to calculate and how you have to rearrange. So I hope that really helps, and that brings us to the end of our video where we solved these 6 very important questions. They were from basic concepts to the area between the curves, which is our ultimate chapter on integral so far we have done. I hope that really helps to review the whole concepts. Feel free to write your comment, share your views. If you like and subscribe to my videos, that'd be great. Thanks for your time and all the best.